Assalamu alaikum. Good time all of you and welcome to our presentation for our project. This is Sadia Fin Mishti in front of you for third batch of CSE department. Our project is multifunctional smart wheelchair for disabled people. Firstly, I would like to thank everyone and especially thanks to our honorable teachers and our supervisor sir, Mohammad Shamrat Ali Abukal sir, lecturer and coordinator evening, Department of CSE. As my project partner, Kim Salman Hussain is with me. Now I would like to talk about our project outline. First, introduction or overview of our project. Then objective. What's the purpose with the project? Motivation, our main motive for this project. Then related work. Which type of work is done? Next, field of services. In our project services who are included. Then required equipments. Which types of tools are used in this project? Then features, the shape or types of our project. Then cost analysis. Here we compare the cost of our realistic project with an existing project. Then future plan about our project and conclusion. Next, I would like to discuss in details of our project outlines. First of all, introduction our project. Human being is the most beautiful creation of the universe, but much unexpected and accidental disabilities or autistic by born, and also some old age persons are feel very helpless and disappointed to lead their life. So to make their life easier, the first thing that comes to mind is wheelchair. And if it's a smart wheelchair, then is useful for everyone. Smart wheelchair is mechanically controlled device designed to have self-mobility with the help of the user command. This reduces the user human effort and force to drive the wheels for wheelchair. Furthermore, it also provides an opportunity for visually or physically impaired persons to move from one place to another. Smart wheelchair has gained a lot of interest in the recent times. These devices are useful especially in transportation from one place to another. Then I would like to say about objective, and this is the main purpose of our project. Most of the disabled persons depend on others for taking them wherever they want to go, and those who use wheelchair also depend on others for steering it. They will always feel it difficult to rely on others and cannot be independent. So I can say that hopefully this project is to help physically challenged people, and it will be basically very helpful for those who cannot able to walk. After that, motivation. Our main motive is we provide physically challenged people independent mobility. For that, they need a wheelchair which can be easily provided to them, and it should not be expensive. Another motive is to make handicapped person productive for their own growth and also for nation. Now I'm going to tell about related work. A lot of work has already been done with the wheelchair. Those are power wheelchair, manual wheelchair, smart wheelchair using Android smartphone. Now I would like to say in details. Firstly, to be said that power wheelchair. Presently in the market, power wheelchair are available but are not affordable for common people. Power wheelchair are using high power battery and super torque motors, so proportionally it's much costly. This motion provided the chair by the use of joystick and toggle switch, and 90 to 95% handicapped cannot drive those wheelchair. So they require an attendee or a caretaker with them. Then manual wheelchair. Manual or traditional wheelchair are also that type of wheelchair. Since middle class people cannot use power wheelchair due to high cost, and this chair cannot be operated without the help of any attendee or anyone. So our multifunctional smart wheelchair will help those people to easily use and move on its own. Afterwards, smart wheelchair using Android smartphone. This project, they divide a smart wheelchair system with voice recognition and touch control using an embedded system. This system is divided into two main modes, voice recognition mode and touch mode. The wheelchair will move according to the command. For the touch mode, the user can select the specified direction displays within the 4 quadrant on the screen of the Android smartphone to control the wheelchair. But if user unable to use smartphone, then these wheelchair are not useful. Then I'm going to next slide. This slide is field of services in our project. We are given services mainly for disabled persons, physically handicapped, and old ages persons. Next, required equipment. Here are the tools which are used in our project. We use Arduino Nano. This microcontroller is used for control and data transmission by AC05 Bluetooth module. Then we use motor driver L293D. Motor drivers amplifies the TTL output of the microcontroller such that it can drive the respective actuators. This IC is used for the switching the relay driver. We use dual channel relay module, AC05 Bluetooth module, touch sensitive switch, single channel relay module, DC motor, wheels, battery, breadboards, LED bulb, 360-degree rotation wheel, reflexive sensor, joystick, transformer, and adapter. We can use some cables and connectors, PCB and breadboards, push buttons, switch, buzzer, and also some jumper wire. Next, I would like to discuss about features of our project. Actually, our project has multifunctional interfaces like touch sensitive switch. This feature has applied in our project. Use of touchscreen enables less muscle movement and less muscular pressure than the self-propelled wheelchairs which are being used from ages. It enables a disabled persons to move around independently using a touchscreen application which is interfaced with motors through microcontroller. Then we have used Android phone in our wheelchair, which is controlled by Bluetooth module to operate wheelchair. Then we also have used joystick. Joysticks are basically a simple arrangement to contact switches at 4 quadrant. It translates the movement of a plastic stick into electronic information. It is processed through a controller. We have enrolled another feature like avoid obstacle and fall detection by LRF module. For this system, by this module, if unfortunately obstacles come or wheelchair is fallen, then it throw a panic alarm and wheelchair is stopped. Then we have applied an extra feature which is stair climbing. The manual wheelchair or smart wheelchair that we usually see are not suitable for climbing stairs. Even use of some wheelchair includes climbing technologies, which is very costly. But with the help of these technologies, our wheelchair is able to climb stairs very easily by 360-degree rotation wheels. By this system, it is possible to climb the road from the sidewalk and also to drive on uneven roads very easily. It helps physical disabilities people more productive. Moreover, we attached LED lights in our wheelchair for night vision. As a result, user will get extra facilities to move at night. Now I would like to call my project partner, KM Salman Hussain, discuss in details rest of the part of our project.
Thank you, Sadia Afrin Misti. Next slide, please. Block diagram. Now I am talking about block diagram. Here is the block diagram of our wheelchair. We can see from the diagram that the microcontroller works as a core element of the project. Microcontroller, motor driver, Bluetooth module, and all other elements are connected with power supply. The Bluetooth module, LRF module, joystick, touch sensitive switch, push button are works as input devices. Motor, piezo buzzer, LED light are works as output devices. When a command is given by the user in the smartphone, Bluetooth module sends that to microcontroller and it works according to the command. On the other hand, joystick, touch sensitive switch, push button, LRF sensor gives digital command and the controller control the motor according to given command. Next slide, please. flowchart diagram. This is the flowchart diagram of our project. Next slide. Cost analysis. We have done a demo project instead of a realistic project for this pandemic situation and economic problems. We have done cost analysis of the demo project and realistic project also. First, demo project. For the demo project, our total cost is 98 US dollar. If we convert this in BDT, then it is 8,134 taka only. Realistic wheelchair. If we use the main system to make a realistic wheelchair, then the cost will be 201 US dollars, which is about 16,683 taka only. Now here we compare the cost of our realistic project and an existing project. There are many existing works with individual function, but as our project is multifunctional project where we have combined many features to create a wheelchair and an extra feature that is like wheel can go up and down the stairs, so we compare with similarly features wheelchair. Next slide, please. First one is stair climbing electric wheelchair. Brand origin Fabio Medical Equipment. Model FBO B11. It offers multifunctional features like lifting devices, mobility scooter, stretcher, power wheelchair, manual wheelchair, mobility stair climbing for manual wheelchairs. And its price in BDT is 1,40,000 taka, which is in US dollar 1,686 taka. Then the second one is, next slide please, electric smart wheelchair. Its model is KY119Y. Its brand is K Young. Features: Smart PG UK technology system controller, power and speed display, automatic alarm and lock, 360-degree turning, crossable obstacle according to height standard, and its price is 662 US dollars, which is 55,000 taka in BDT. Thinking about our country, it is much more expensive and not available, but keeping this stair climbing, mobility scooter, obstacle avoidance with LRF module and panic alarm, Android control joystick use, touch sensitive switch, LED light bulbs for night vision features in our wheelchair, the cost is much less and user friendly following those two types of wheelchair costs. Next slide, please. Then the future plan of our project. Our main target is that the whole country will be brought under our services. Mainly those are must be needed using wheelchair. And in future, our plan is we include another function like eye control detection system, a design of a microcontroller based wheelchair controlled by the motion of the eyes. The user wears a set of electronic eyeglasses used to detect the movement of the sclera of eyes and then transmits control signal to the wheelchair via Bluetooth. The sensors can detect 4 directions of eye movement: half left, half right, full right. Alternate power source. Solar panel roof can be used as alternative power source, and it also can be a protective layer from rain and sun. GPS navigation. Navigating the actual position of the wheelchair. Mind control. Controlling wheelchair by electric signal coming from brain, as our brain contains thousands of neurons. there is certain potential difference between each neurons. When we think about something, neuron emits 0 to 50 hertz electronic signal. By interpreting the signal by modulation or demodulation, we can control the chair. Gesture control. Gesture control is the ability to the hand motion through the left gesture of left and right, and recognizes and interprets movement of the human body in order to interact with the control a computer system without direct physical contacts. Next slide, please. Conclusion. We are confident that this system has considered and designed to make lives better for the disabled society, and we hope that we will make it better use for them in future. Now I want to show our project video. So Sadia, please put off your headphone and play the video, please.
Okay.
Hello everyone, here is our project Smart Wheelchair. Here is the overview of our wheelchair. In the front side we can see two motor and air sensor and 360-degree rotation wheel. From the side we can see two motors, and from the behind we can see a battery and a power switch and a charging port. Now from the side we can see a IR sensor, then a motor driver, and then touch sensitive switch also. In the opposite side there is a light sensor also, a single channel relay module. In the front, dual channel relay module and a light sensor. Here we can see the touch sensitive switch and joystick. Now this is the chair where the patient can sit to operate the wheelchair. In the center we can see the Bluetooth module, our nano microcontroller, and some jumper wires also, and this is the piezo buzzers. We need to download an Android app from Google Play Store to operate the project with smartphone. Now we have to make a interface for operate our wheelchair. So we make the interface according to our coding. Now we have to connect the smartphone with the wheelchair. So we have to connect with Bluetooth. So we have to first discover, then pair. I already paired, so I have to just connect with HC05 Bluetooth module. Now connect and done. Now we can operate the wheelchair with smartphone. Here is the interface of the application that we have designed before. This is forward, this is backward, this is right, and then this is left. Here we can see the stair wheels that will help to climb on stairs. Now this is time to operate the wheelchair. First we have to power on the power switch, then we can see the light in the microcontroller, then we have to touch the sensor. When we touch the sensor, then the wheel starts rotating. Now when we touch the sensor, the wheels are rotating. Now we have to check the left right direction. This is left, then this is right. Now this is time to operate the wheelchair with the joystick. This is forward, now left, and then right. Now this is time to check the obstacle avoidance of our wheelchair. When a obstacle comes from the side, from the front, and from the other side of the wheelchair, the buzzers starts beeping. When anyone hear the sound of the buzzer, then anyone understand that something is happened. Here is some footage when we are operate the wheelchair. We can see that we can operate the wheelchair perfectly. Now we have to see that how can our wheelchair climb the stairs. For this, first we have to make a demo stair, and then we have to turn on the stair wheels. Here we can see that our wheelchair can climb the stair fluently. Now this is time to check the obstacle avoidance. Here we can see that when an obstacle comes in front of the wheelchair automatically turned off and it gives the panic alarm. Now we cannot operate the wheelchair. Now take another look about obstacle avoidance. Here we can see that our wheelchair can detect obstacle and can avoid obstacle by the help of the LRF sensor. Our project have another feature, that is fall detection. Here we can see that when our wheelchair fall down, then the piezo buzzer starts. When anyone hear the sound and pull up the wheelchair, then the piezo buzzer turn off. When the wheelchair fall down, then we cannot operate the wheelchair with any controller. Now we can see this practically. When the wheelchair falling down, then it cannot be operated. That we can see in the video. Now thank you for watching this video.